This lecture on A255 Programmable Peripheral Interface. So actually this particular peripheral interface IC, that is A255, is used in the interfacing of microprocessors or microcontrollers with the higher number of external devices that if the particular microprocessors are having very limited numbers of ports. So extending the numbers of ports will be done by this A255 Programmable Peripheral Interface IC, so that it has been used extensively in the designs of embedded systems using 8085 or 8051 and in the higher performance ICs also, higher performance microprocessors also. So we will be seeing the internal architecture and the pin diagram and other working notes in this particular video. So this is the pin diagram of A255. So A255 is an 40 pin DIP package IC. Here you will be having three numbers of ports to be interfaced with the external devices and your microprocessors. So the ports are port A. So port A is started from PA0 to PA7, and port B is started from PB0 to PB7, and port C having two numbers of 4 pin ports. That is the first port will be P0 to P3, that is the first 4 pins, and the next 4 pin is going to be PC4 to PC7, that is the next 4 pins. So this particular port C may be bit programmable, or it may be used as a control of modes of operations in this A255. So the controlling operations are done using this port C, and this port C can be a bit programmable also. So by that way, this 3 ports can be grouped into 2 groups. One is group A and another one is group B. Group A having port B and the port C first quarter, that is the PC0 to PC3 are going to be grouped as in group A, and port A and PC4 to PC7 are going to be grouped as a group B. So by that way the modes of operation are going to be designed by these groups by taking care of this particular grouping of port values. So depending upon the values, we will be grouping that particular ports. And in order to control this particular operations of A255, we will be having the control pins as read, write, and A0 and A1 will be used for choosing the port addresses. That is, whether we are going to use port 0 or port A or port B or port C, we will be choosing by using A0 and A1, and VCC is going to be plus 5 volts, and ground will also be used, and reset pin is also exists in this particular IC, and chip select pin is going to be active low signal, and read and write signals are also going to be active low signals. So this A255 can be accessed by this particular 3 numbers of ports by choosing the appropriate value for the A0 and A1. The chip select is going to be selected for enabling this particular ports. So if you want to enable this particular ports, you have to first give this chip select pin as 0, and appropriately you can select the values of A0 and A1. For port A, the A0 and A1 value will be 0, 0, and for port B it is 01, that is A1 A0 will be 01, and port C will be 10. A1 A0 will be 10 for port C, and if you want to choose the control register for operations, that is this control register can be only is going to be writable, it is not readable at all. So this particular writable property of this particular control register is going to be accessed by giving A1 A0 A as 1 and if this particular chip select pin is not been selected, that is if it is being given as 1, then 8255 is not being selected. So this is the internal architecture diagram of 8255. So here you can notice that group A having port A and port C's upper pins, that is going to be group A, and group B port C's lower pins and port B's pins are going to be group B. So here you will be having the control registers for that is the control blocks for the group A and group B as separate, and these control operations are going to be controlled by this read and write control logic. So here you will be having the control register. So this control register is going to be controlled by this particular 5 numbers of control pins, that is read, write, A0 and A1 and reset pins, and the data is going to be transferred by this bidirectional data buses, and this data bus is going to be controlled by the data bus buffer, and this data bus buffer is going to be connected with the ports by the 8-bit internal data buses. So here a nice diagram has been given for controlling operation of the port pins. So the ports A, B and C are going to be controlled by the grouping operation. So the lower that is a higher pins of the port C and the port A will be controlled by the group A operation, and group B operation is going to be given by the lower bytes of the C and the port B, and these control pins are going to be controlled by the control logic and the control register, since the control register is going to control this grouping operation, and also this particular control register is going to select whatever the mode is going to be operated in the case of 8255 operation. And the internal decoding is done by the pins A0 and A1 and chip select, and how this particular internal decoding are going to be done, or how we can use this particular A0 and A1 pin can be given as an example in this particular video itself. So this is the 8255 controller. So you will be having the group B as port B and port C's lower byte addresses. So so in this particular controller, the ports can be programmed as either as an input as the or output, or it can be used in the either form of the modes of operation is going to be programmed. So the modes can be explained in this later of this particular video. So the mode selection is going to be done for the separate for the each and every group. So for the group B, you will be having the port B. So by putting the appropriate bits for this particular pins. So if it is going to be 1, then it is going to be input. If it is going to be 0, then it is going to be output. So this first pin is for port C's lower byte addresses, and this second pin is for second bit is for port B, and the third bit is going to be for mode selection. So if you are going to use the five modes of operation, the five modes of operation can be programmed by this particular control word. So in this particular word, that is in this particular D2, you can select either mode 0 or mode 1. So from the D3 to D7, D6, you will be having the operations of group B. So in this D3, you can program the ports is upper byte addresses as either as input or output, and port A by the D4th bit, and D5 and D6 are going to be used for mode selection. So in this particular operation, you will be having mode 0, mode 1 and mode 2. It can be chosen by the appropriate mode selection bits, which is given here. And this D7th bit is going to be used for either input output mode or as a BSR mode, that is the bit set or reset mode. So the difference between these two modes are going to be given as follows. Bit set and reset mode is going to be only used for the port C pins. So the port C consists of 4 bits of 4 pins of ports. So the port C having 8 pins. So first 4 will be the lower byte pins, and second is going to be higher byte pins. So this 8 set of port pins can be programmed as an bit programmable pins. So that kind of mode is going to be bit set or bit reset pins. So that is the different mode. Input output mode can be classified into 3 kinds of modes. So that 3 kinds of modes can be selected by the mode selection pins, which are being given in this particular D5 and D6, and also in this particular D2. So D2 is going to be programmed when the group B pins are going to be operated, and D5 and D6 are going to be operated for mode 2 also. So for mode 2, you don't have to worry about this particular D2 pin, but for mode 0 and mode 1, you have to select this particular appropriate bits for the D5 and D6, also for the D2. So that is the setting of the control word is given in this particular 8255. So depending upon the mode, you need to select the appropriate pins and appropriate bits for the given control word. So this control word is particular representation of the control registers values. So here you will be having the 4 operating modes for the 8255. So first mode is going to be mode 0, that is simple input output. For any of this particular ports, that is port A, port B and port C, that can be programmed as either as an input or as an output. So that can be programmed in this particular controller as either as an input or as output. Mode 1 is going to be input output with handshake, that is this particular A and B can be used for input output, but the C port is going to be provide handshaking signals. So port A and port B are going to be port pins, but the port C is going to be used as a handshake signals. Handshake signals means this particular signals are going to be used for communication of this particular port A and the port B with the external devices. And mode 2 is going to be used for the bidirectional with handshake. So here the input output is going to be single direction, that is if you are going to use that particular pin as an input, that is only being used with the input mode. And and if it is going to be used as an output, then that is going to be only as an output, but this mode 2 is going to be bidirectional. So at a time you can use these pins as either as an input or as an output at a time. So A is a bidirectional with C provides the handshake signals. B is a simple input output. So B is going to be programmed as in mode 0 and mode 1. So that is the handshake input output mode. So the B in this mode 2, the B is going to be programmed as a simple input output mode or as a handshake mode, but A is going to be bidirectional with C provides the handshake signals. So this bit set reset mode, as I have mentioned, only C is available for bit mode access, allows the single bit manipulation for the control applications. So here I have given the definition summary of this particular 3 modes of operation. So here I have given only 3 modes of operation of input output mode. I didn't give the BSR mode. For mode 0, this particular 3 ports are going to be programmed either as an input or as an output. In the mode 1, you will be having the port A and port B as an either as an input or as an output, but the port C is going to be used for the handshake signals. So what are the handshake signals are interrupt request, input buffer full or output buffer full. Here it is given as output buffer full, acknowledgement and strobe. So these are all the control signals are going to be used for the mode 1, and for the mode 2 you will be having the group A is going to be as a bidirectional one, and group B is going to be used as an either as a mode 0 or as a mode 1, but the port C is going to be used as a some control signals for the bidirection and the group B's mode 0 or mode 1 operation. So for the mode 1 it is needed as handshake signals, but for mode 0 this particular pins are going to be used as a separate non-addressable pins. So in the mode 0, it provides the simple input-output operations for each of the 3 ports. So no handshaking is required. Data is simply written to or read from the specified port. 2 8-bit ports and the 2 4-bit ports can be used in this particular mode. So one example can be given for this particular mode in the last of this particular video. Any port can be an input or output. Outputs are going to be latched and inputs are going to be delatched in this mode. Mode 1 operation, the basic functionalities are two groups, that is group A and group B are going to be used. For each group, one 8-bit data port and one 4-bit controller data port are going to be used. So either port A or port B are going to be used as a 8-bit data port, and in the group C for the group but in the port C, the group A is going to be port A and the higher byte of the C port, and for the group B, port B and the lower byte of the port C is going to be used. 8-bit data port can be either as an input or an output. Both inputs and outputs are going to be latched. 4-bit ports is used for controlling the status of the 8-bit port data port. So this is a depiction diagram of 805 mode 1 output operation. Here you can notice that this is for port A. Port A 0 to port 7 are going to be used as an output port, so that is going to be programmed here. The D1 pin is going to be given as a 0, so the port B and D2 is going to be 1, so mode 1 and port B is going to be used as an output pin. So this has been selected here, and port C, 4 and 5 pins are going to be used as an 1 or 0. So this can be programmed for this particular operation. And input output mode, it is going to be given as in 1, because we are going to use this for mode 1, so that is going to be in input output mode, so we will be selecting 1. And port A, it is going to be mode 1, and port A is going to be output mode, so that is being selected here. So here for port B we can choose others also, that is this particular pins bits are going to be used are going to be set for port B. It is an output and it is going to be operated in the mode 1. So here the PC7 and PC6 are going to be used as an output buffer full for A port and acknowledgement for the A port, and interrupt request pin, that is the PC3 is going to be used as an interrupt request for A port. And for the B port also we can have the different port C pins, that is the output buffer full. That is why we are using this output buffer full means, so if the output, that is the output word that is being given from the 8255 to the external device, if that particular external device buffer has been full means that particular thing is being noticed in this particular port pin. So by checking this particular PC7 or PC1, we can be informed that the particular external device that has been connected in this particular pins are getting the output buffer of that particular device is being filled, so the communication have to be stopped. So that is understood by that particular microprocessor when the communication is established between the microprocessor and the external device. So for that purpose we are going to use this particular output buffer full operation. Acknowledgement and interrupt request. So whenever we are giving the interrupt request, that particular device have to give the acknowledgement through this particular PC6 and the PC2 pins. So by acknowledging, the data bus is being given for as the output for that particular device. So here the control signals are given. So next we are going to see the mode 2. So mode 2 is going to be bidirectional. So bidirectional for the port A. So that particular port A is going to be programmed as an strobe bidirectional bus input output. So it is used in group A only. That is the port A is going to be only used in the mode 2. So port B is going to be either programmed as an either mode 0 or mode 1. So both inputs and outputs are going to be latched. So one 8-bit, that is the group, that is the port A, is going to be used as a bidirectional bus, and another one is being used as an either as a mode 0 or mode 1. So the output operations can be output buffer full, acknowledgement, and the strobe. So this strobe is going to be a low signal, active low signal on this input, loads the data into the input latch. So this particular control word is going to be used when the input is being loaded as an data. So input buffer full is going to be used for indicating whether the particular 8084 or 8254 buffer is being full when the external device is writing in the 8254 buffer. So when this particular buffer is being full, then that is going to be indicated in this particular control pin. So by checking this particular control pin, we can select that, we can know that particular buffer is full. So the operation have to be halted for some time to evacuate the particular buffer. So this mode 2 is programmed here. Here mode 2, mode 2 and mode 0 has been programmed. For mode 2 it is for port A and mode 0 is for port B, and here we have programmed that mode 2 is for port A and mode 1 for port B. The control words are being given. PC3 is going to be used as an A ports interrupt request pin, and this is for out. The PC7 is being used for output buffer fill and acknowledgement signal for the A port, and the strobe signal for the A port. So these two signals are going to be used for the acknowledgement and the strobe, that is when the input is being got from the external device. So this is the input buffer fill that is going to be used in conjunction with this particular strobe pin. Here the PC022 is going to be used as an input output pin. So PB0 to PB7 is going to be used as a mode 0, that is the input pin. So we can program this particular configuration as the control word which has been given here. Here the PC0 to 2 is going to be given either as in 0 and 0 or 1. So depending upon the values which are giving, we will be giving this particular value, and D1 is going to be 1 and D2 is going to be 0, and others are going to be as don't care pins, and D7 is going to be as 1 because here we are going to use this as an input output mode. Either we are going to use it as a mode 0 or mode 2, mode 0 and mode 2. So this pin is going to be 1. So D5 and D6 are going to be used as a mode 2. So it is going to and this D5 is going to notify that either as a 0 or 1. So whatever may be written, we can use this particular mode 0 as an input. So we need to give the X as a 0 here, and here also we are going to notify that mode 1 is going to be output mode. So this pin is going to be 1. So whatever may be the condition we need to apply, we can apply by using this particular control word. So BSR mode is going to be programmed by the by setting this particular D7 pin as a 0, that is bit set and reset flag is going to be 0. Then this particular 8255 is going to be programmed as an BSR mode. So in the BSR mode, the P0 to P7 are going to be used as an as bit addressable. So each and every bit can be programmed as such we want. So the bit set and reset pin are going to be this D0 is going to be either set or reset. So depending on the value which are we are giving, we can notify that. So bit is being selected by D7, D1 to D3 bits. So here you can notice that the 0, 1, 2, 3, 4, 5, 6, 7 up to these values are given. Here you can notice that B0, B1, B2 are given. So whatever may be the values we need to give, so that that value can be given as we have given in this particular chart, and each and every bit can be selected by this particular modes which are given here. So here we are given a particular example for this particular mode 0 programming. Here in this particular slide we have given that how we are going to connect this particular 8255 chip with the external device and the 8085. So that is this particular 8255 is connected with the control pins as like this. here A0 and A1 are connected with the address pins of the 8085, as A1 as connected to the A1 and A0 is connected to the A0, and this chip select pin is going to be selected by using the A2 to A7 bits of the 8085. So here, since this A7 is connected directly to this particular NAND gate, so this A7 can be given as an 1, and A2 to A6 are going to be connected with this NAND gate with the input and NOT gates. So this A2 to A6 are going to be always 0. So whenever whatever the address is being given here, if this particular pins are going to be selected, then this particular NAND gate is going to be given with 0000. So if all the address lines are going to be connected, then this chip select is going to give the address as like this. So 10000 has been given, and A0 and A1 are going to be either as 0001 or 10 or 11, depending upon the ports whichever we are going to use. Either we can be connecting with the port A and port B and port C, and control register can also be accessed by this particular hexadecimal addresses. So if you need to access this particular port A, then the hexadecimal address is going to be, so we can segregate this 1000 as 8 and 0000 as 0. So we can have the access of port A, and 8 and 1 hexadecimal address, then it is going to be port B, and A2 as port C, and A3 for control register. So by using this particular chip select logic, we can program, that is, we can access these particular ports, port A, port B or port C, or control register as such we want. So here we are being given with a particular circuit diagram that we are going to connect this particular chip select. There is A15 is going to be connected for this particular chip select, and we can use this particular control logic here, and A1 A0 is being connected with the directly to the particular A1 A0 pins, and memory read and memory write signals are going to be connected with the read and the write signals, and reset pin is going to be connected with the reset out of the 8085. So here A0 to PA0 to PA7 are being connected to the LEDs, and PC0 to PC7 are connected with the buffers, whatever may be the buffers we need for the LEDs. We will be using the separate buffer for the LEDs and separate buffer for the dip switches. So this dip switches are being connected to the port B, as we have mentioned in this particular diagram. So since the connections are being made, here you can notice that this particular 83H address is used for control register. So for choosing this particular control register, we need to have this particular D7 as input output function, because we are going to program for mode 0, so it is going to be input output function. Since we are going to use this particular port here for mode 0, so we will be choosing 0 0, and port A output is going to be used, so this particular D4 is going to be used, going to be set as 0, and port C's upper bit is going to be used as output, so we will be choosing 0, and port B in mode 0 is going to be used, so it is going to be 0, and D1 is going to be 1, since this particular port B is going to be used as an input, and port C higher bit is going to be used as an input. So here we are going to load this particular 83 hexadecimal address into the accumulator. Since this particular control logic is going to be used for this particular accessing of this particular control word, we need to give this particular address to the particular values. So the next thing, it is going to be store accumulator with the 8003 address. So this 8003 address is get from the ports address, and loading of this particular accumulator. For reading of switch of the port B, we need to use this particular address, and for the port A we will be using 800 address, and for the port C reading switches 8002 is going to be the address. So by using these addresses and this program, we can use this particular program for the programming of mode 0 as the port A